everyone, good morning. I hope everyone is okay, is fine, is having a nice time. I'm Professor Dr.Mchem from Dr.Mchem Institute of Chemistry, University of St. Jamshire. And I'm again here with something new, something more interesting, something exciting, something common, and something very interesting to follow. Well, what are electron deficient compounds? Let's talk about the electron deficient compounds. So, of course, let's talk about the octet rule. Octet rule is confirmed by covalent bonding mostly, right? So what that is that the total number of unshared plus the bonding electrons around any atom should be equal to 8 and 2 for hydrogens, right? So the octet rule is also called a duet rule. It is called a duet rule for as far as hydrogen is concerned. It is called a duet rule. So it simply specifies the maximum number of electrons that but it is possible for an atom to hold lesser than 8 electrons. As few compounds have atoms that have lesser 1 or more electron pairs. So to complete their octet, that is 8 number of electrons, 8 electrons, right? And are called electron deficient compounds. For example, now if we take an example of boron trifluoride. Now boron trifluoride has got 6 unshared electrons in its valence shell and is short of an electron pair. So it is the perfect example for an electron deficient compound, that is boron trifluoride. Now, reactions of electron deficient compounds with the Lewis bases. Now, such compounds have a nature to react with to complete their octet, that is their valence shell. So in this type of reactions, the compound that is electron deficient, it tries to react with such a compound that contain more than one unshared pair of electrons. For example, now reaction between boron trifluoride and fluoride ion. Now here the electron deficient compound is acting as a Lewis acid. Now what is a Lewis acid? Again, something new. An acid that accepts an electron pair in a chemical reaction to form a new bond is called a Lewis acid. Now here we can simply see a reaction between boron trifluoride and a fluoride ion forming tetrafluoroborate ion. Now here the electron deficient compound is acting as a Lewis acid, that is this one, it is acting as a Lewis acid as it accepts an electron pair from the fluoride ion forming a BF bond, that is this one, BF bond. Okay, so and what would be the name of this compound? Tetrafluoroborate ion. Whereas the compound that gives the electron pair, right, that gives the electron pair to the Lewis acid forming a new bond is called a Lewis base. Okay, here fluoride ion is a Lewis base, that is this one, it is a Lewis base, okay, because it has shared its electron. Here fluoride ion is a Lewis base. Now such type of reactions are simply called Lewis acid base association reactions. Now what type of a reaction is this? It is simply called acid base association reactions, in which a Lewis acid and a Lewis base, they add up to form a single product having each atom a complete octet, right? A complete octet, you can see each atom is having a complete octet, right? So such type of reactions are simply called as acid base association reactions. I hope you understand these lines and this reaction. And this in here you can see this is acting as a Lewis acid, and this fluoride ion, it is acting as a Lewis base, and they add up to form this tetrafluoroborate ion. So this was something interesting to note down. So what was the result of this reaction was that they each atom of this compound has got an octet of 8. It has formed its octet. It has all 8 electrons surrounding them, right? So this was one of the benefits of it. And one more thing is very important to say, that the completion of this octet, it provides you can say a very strong driving force in the reaction. Now, one more thing is very interesting to note down here, that Lewis acids are also called electrophiles. Now, electrophiles means it has a Greek. It is from the Greek word electron loving. That is called electrophile, means loving, electron loving. So, and the opposite of this is you can say Lewis acid is the Lewis base, and that is, of course, it's something to do with nucleophile, right? Nucleus loving. So this is actually a term that is used synonymously with the Lewis base, and it is called simply it is you can simply call it a Lewis base in the organic reaction, and it is also called a nucleophile, that is nucleus loving. So this was something interesting, and I hope you understand today's reaction, today's lecture, and this will help you out in understanding the Lewis acid base association reactions. Thank you very much. So we were talking about the Lewis acid base association reactions. Now if we just see the reverse of it, the opposite of that reaction is, this could be called as you can say Lewis acid base dissociation reaction, right? That is the opposite of association, that is dissociation reaction. That is if we detach or separate fluoride ion from BF4, that is boron tetrafluoride ion, what will happen? It will again become boron trifluoride and with the fluoride ion, left with only fluoride ion. This would be the reverse, or you can say the opposite of the Lewis acid base association reactions, which we can call it as Lewis acid base dissociation reactions, right? So now a question arises that, for example, if you have two compounds, that is aluminium trichloride and a methane. If you have aluminium trichloride and methane, now from the following compounds, which one would react with the Lewis base, that is chloride ion, in this Lewis acid base association reactions? Which one would react? So let's solve that. Now here, these are the two compounds, that is methane and aluminium trichloride, right? Now as we know that compound can only react as a Lewis acid in the association reaction if it could only accept a pair of electrons from the chloride ion, that is a Lewis base. So in the above compounds, aluminium trichloride is deficient. Of course, yes, it is deficient to obey the octet rule. That is the octet rule by only one electron pair. So is an electron deficient compound and is ready to get a pair of electrons from the chloride ion, and it's called an association reaction, right? So it is deficient of only one electron pair, right? This Lewis acid, and of course this chloride ion is acting as a Lewis base, so it is ready to get an electron pair as shown here, and it becomes this compound. You can see here now you can see all the chloride ions, they are obeying the octet. Their octet is fulfilled, right? So whereas if we talk about methane molecule, right, this methane, right, where a carbon is surrounded by 4 hydrogens, where all atoms, of course, they have the noble gas number of electrons, that is carbon 8 and hydrogens 2. What they are proving, that methane is not to be an electron deficient, right, and unable to follow Lewis acid base association reaction. So this compound is unable to follow the Lewis acid base association reaction. I hope now you understand and you follow through this example what are Lewis acid base association reactions and what are Lewis acid base dissociation reactions, right? So I hope you have followed and you have understood this and you have enjoyed this simple example, and you will learn it, and please learn more examples like that because they can come in your exams, they can be asked from you in your viva voce exams. So let's be prepared, and let's again get back to your studies with this topic. Keep this topic in your mind. Let's connect again with something new and something more interesting. Thank you very much.